Hello friends, this video on application of derivatives part 28 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 27. One more example. We have to show that the rectangle inscribed in a given fixed circle has maximum area. So we have this circle. Inside this circle we have this rectangle. So the question says that you have this circle, in this you inscribe the rectangle, the one which has maximum area has to be a square. That is, in this case, both the sides will be. That is what the question says, and that is what we have to prove. First thing, is it the question of absolute maximum minima? No, because the range in domain is not defined. So let's take my R here. How should we proceed? This is my center, 0, 0. How should we proceed? In this question, we have to prove that if my sides are x and y, I have to prove that x is equal to y. Correct? To prove x is equal to y, for area to be maximum, that is xy is equal to max. That is why we have to prove. We have to prove that x is equal to y for xy to be max. Correct? So if you join these lines, what I'm trying to do is, I'm trying to get a relation between x and y, so that I can write the whole thing in terms of x, and then I can find the value of x for which this is max. This is r, this is r, this is 2r, this is x, this is y. So my Pythagoras theorem says that x square plus y square is equal to 2r whole square, because the right triangle. So my y is nothing but root of 4r square minus x square. This is my y. I have a function xy because that is the area function, and I have to find the value of x for which is maximum. So replace y with this guy. So root 4r square minus x square. So I have to find the maximum value of this, or I have to find the value of x for which this function is maximum. Same thing, first thing we'll differentiate this guy. So this becomes, if we differentiate this guy, this is nothing but, first time make this constant. So this becomes 4r square minus x square. Next time make this constant, differentiate this guy. So this becomes 1 by 2 4r square minus x square into 1 by 2 into x square, differentiation is minus 2x minus 2. By chain rule I have done. If you are having issues in this, again watch derivative chapter where we have explained how to derive such kind of equations. So f dash x is this one. Correct? You solve this further. This is nothing but root of 4r square minus x square, and this gets multiplied. So this becomes 4r square minus x square, and this becomes minus, this cancel, minus x square. So this is nothing but 4r square minus 2x square by root of 4r square minus x square. This is the value of f dash x. Now for this to be maximum, this guy has to be 0. So this guy has to be 0, that is f dash x has to be 0, or 4r square minus 2x square by root of this guy has to be 0. If this is 0, my denominator is 0, so I can write this as nothing but x is nothing but root 2r. If you solve this, you'll get the value of x to be root 2r. How? This guy is 0, so 2x square, I'll solve it here. 4r square minus 2x square is equal to 0, or x square is equal to 4 by 2r square, or x is equal to root 2r. I'm not taking the negative part because x is the length, it has always to be positive. So x is equal to root 2r. If x is equal to root 2r, let's find the value of y. Y is nothing but this guy here, root of 4r square minus x square, that is root 2r square, and this is nothing but root 2r. So if you see x and y, both are root 2r, so I can say that x is equal to y, and that is what I was supposed to do. Now there's one more step here actually which I am missing, that is I knew that root 2r is a critical point, but I have to find f double dash x also. If you find f double dash x, you have to prove that this guy is less than 0. Sorry, f double dash of root 2 r is less than 0. So first thing is you define f double dash x, and then you define f double dash of root 2 r and prove that this is 0. So this is I left on students. Students can solve this, very not that difficult. You have this function. For this function you define double derivative and find the value of f of root 2 r. This will come out to be less than 0. Let's take one more example. The question says we have to show that the right circular cylindrical of given surface area is constant, and maximum volume such that height is equal to the diameter of the base. So the question says we have this cylinder, we have this height, and we have this diameter. Let's suppose we have radius r, diameter is 2r, and diameter is also equal to the height. So h is equal to 2r is what I have to prove. I have to prove this if V is max, if volume is maximum. Correct? What is given? Given is surface area is constant, volume is maximum, right? And to prove h is equal to 2r. These are given. So let's see what does it mean. It means that if you find SA is nothing but 2 pi RH plus pi r square into 2, and this is some constant, it is k, correct? And my volume is pi r square h. I have to find the value of r for which this is maximum, volume is maximum, correct? The first thing I have to do, I have to convert this guy into r term only. I have to, instead of h term, I want it r term here. How can I get that? I have one more equation, that surface area is constant. So with that I can get h is nothing but some constant minus 2 pi r square divided by 2 pi r. So I'll put this h here. So this becomes pi r square into h. H is nothing but k minus 2 pi r square by 2 pi r. Correct? And if you see pi cancel, r square cancel. This is nothing but r by 2 into k minus 2 pi r square. This is my volume in terms of r. Now I have to find the value of r for which this volume is constant, correct? V is constant. So for this, what I can do is I can find the value of dV by dr and I can make it 0. So whatever r I get, that is a point where this volume will be maximum or minimum. So let's find dV by dr. So for this, if I want to find dV by dr, so this I can further write as k r by 2 minus pi r cube actually. So this is nothing but dV by dr is, if this is V, dV by dr is k r by 2 will become k by 2 minus 2 pi r cube will become 3 pi r square. Correct? And this is equal to 0. So with this, my r will be nothing but root of k by 6 pi. This is the value of r, but we don't know whether in this case it is maxima, minima or inflection. Correct? So for this, we have to find d square b by dr square. Second differentiation. So dv by dr is this. So if you double differentiate this, k by 2 becomes 0. Minus 3r square becomes 6 pi r. This is nothing but minus 6 pi r. That will always be less than 0 because r is always positive. So this is always less than 0. So this guy is always maximum. Thus my r is k by root k by 6 pi. What I have to prove? I have to prove that this r is equal to h by 2, correct? Or h is equal to 2r. Let's find the value of h. H is nothing but k minus 2 pi r square by 2 pi r, correct? So let's put this value k minus 2 pi. What is the value of k? K is, we know that, this guy, correct? That is k is 2 pi r h. Now if we can find the value of k here, I'll put the value of k, everything will be in terms of r. So this equation I get r is equal to root k by 6 pi. If you square both sides, r square is equal to k by 36 pi square. K is equal to, if you see, 6 pi square, 6 pi actually. So k is nothing but 6 pi r square. K is nothing but 6 pi r square, correct? So I'll put this guy here. K is equal to 6 pi r square minus 2 pi r square by 2 pi r. That is 4 pi r square by 2 pi r. That is 2r. So if you see what we have found, h is equal to 2r, and that is what we were looking for. So what we have done, simple. What we have done was, we have this statement, we convert this into mathematical statements. Surface area is constant, volume is max. We have to prove that h is equal to 2r. Surface area formula we know, that is constant, and with this I got equation of h in terms of r. Volume is pi r square h. To find the maximum value, I have to convert this into a equation that is totally on the r. So I removed, or I replaced h with k minus 2 pi r square by 2 pi r. I got equation of volume in terms of r. I found dv by dr, and I got the value of r to be root k by 6 pi, but I didn't know it is maximum or minimum. I double differentiated this and I found that this is less than 0, so this is the maximum value. Now I have to prove that h is equal to 2r. So I said h is equal to this formula, use this formula, k minus 2 pi r square by 2 pi r. Now I had everything in r, only k part was there. So I knew that I can write k in form of r also. So I wrote this k is equal to 6 pi r square. And then the moment I write this, I simplified this equation, I got h is equal to 2r. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.